All right, we'll go on to the next presentation. Is from Joel Sherrill from OAR, entitled A Year Around the Sun with RTEMS.
Hi, this is an update on generally the same type of presentation I've done the past few years here, where I just kind of want everybody to hear more about what's been going on in the RTEMS community. Next slide. Okay, you get somebody wants video. That's pretty painful. So one of the things I always like to do from year to year is highlight some of the things that have happened on missions. And I'm not going to read this one, but I will highlight one. Anecdotally, somebody told me that MMS had gone 10 years and finally had to have a reset of the hardware, which is the first time they've had that. So, but a lot of these missions have been running a long time, very successfully with RTEMS, and we're very happy when you share your information with us so we can pass it along. But if you don't tell us, we don't brag on you. So next slide, please. So what we're going to do is highlight just a few of the things that have been going on in the RTEMS community for the past year, 14 months. One, try to clarify some confusion things, some a little bit of background on what's going on with the network stack, the ESA qualification effort, some of the hosting statistics and mailing list traffic, and then some discussion on how we're transitioning the network stack and a little bit on Deos+RTEMS. Next slide, please. So the RTEMS versions have evolved quite slowly, but we're hoping this will speed up. 4.10, for those who are tracking, was the last version, which was a pure uniprocessor. 4.11, again, as it says here, was functional but had experimental SMP, at least that's what we considered it. It was worthy of use, but only with a handful of processors, maybe 4 or 8. But 5 has a lot of optimization. It has been deployed on systems up to 24 cores that we know about. It has gone to constructor-based initialization, which shrinks the code size enormously. But one of the things that's coming is that what we refer to as 6 is actually just the master version with the WAF build system. So we are finally converting away from the automake toolset to WAF, and there's only a couple of things left to do, and then the WAF system, the AutoConf system will be removed and the WAF system will be in place. Even as much as we've optimized the AutoConf build system, the build time is at least twice as fast. So it's quite an improvement, and WAF itself is in Python, so it should be more familiar to people than M4. We refer to 7 as a tracking version for bleeding edge tools. So 6 is using the development version of RTEMS with released tool versions. 7 is using the same RTEMS version, but using like a GCC version that hasn't been released yet. If you want to find out how things are coming, or mainly it's for us to test internally, but if you're bold, you can reach out and test the latest GCC. But at this point, 5 and 6 are largely equivalent, with the exception of a few BSPs that have been added. So next slide, please. So I have only been peripherally involved with this, so if anybody asks any hard questions, I probably won't have them. But the big thing to note about the ESA pre-qualification effort is that ESA has done at least 3 qualification efforts for RTEMS in the past and has kept all of the artifacts in-house. This time they are submitting all of the qualification data and the things to create what they call a qualification data package back to the open source project. And those should be, they already have trial versions of these qualification data packages for the 2 Leon 3s listed there. And those should be available soon for public review. So the intention is, and it's happening, is that RTEMS.org, the community, will own and have all of the technical data needed to create a qualification data package for when a user wants to. So there's still work to do. And I think last year, we discussed the space profile. So they're focused on a subset of RTEMS geared for their S&P space usage. So this is a point where anybody who's interested in qualification on RTEMS, or just how qualification can actually be done by an open source project in the open, please join in and review and provide feedback. Next slide. So the network stack status, what we have been trying to do, and we've been very successful, is we have what's called RTEMS libbsd, which actually tracks FreeBSD releases. So we're now on FreeBSD 12 tracking their releases, and a significant amount of the FreeBSD kernel and capabilities are available as add-ons to RTEMS itself. So this gets you the FreeBSD TCP/IP stack running on RTEMS, for example, is a upgraded TCP/IP stack with a lot of capabilities in servers, but it also brings over things like USB mass storage, serial port, USB serial ports, keyboards, mouse, wireless networking controllers. We already have, we brought in support for NVMe storage, SDMMC, and a little bit of graphics. And if you're really bold, you can use the unified memory allocator and the epoch-based reclamation SMP safe support that's in the kernel. It's also available for users. The point here is that we bring over an enormous number of drivers and capabilities, and they are configured and tuned just like they would if you were system administrating a FreeBSD system. So they just work. Next slide. What is in the process of, and this probably won't hurt or impact any production systems that or even future systems. We have a 20-plus-year-old IPv4 FreeBSD stack, and it has had a long and fruitful life. There's someone now working on moving it out into another repository and adding its own build system, and then it's been jokingly referred to as purgatory or limbo. So if you need it, our intention is that it's still there, but that we will focus all future efforts on the libbsd stack, or as people want it, the lightweight IP stack. So this mainly impacts BSPs which don't yet have libbsd drivers, and there's some details here listed. A lot of these have drivers in FreeBSD already. There's a few, though, that don't have drivers and that will need their existing drivers converted to work with the new TCP/IP stack. So you've got options, and we want to work with you so we don't give anybody any unnecessary pain. That's why we didn't just remove this old stack and kill it. We try really hard not to negatively impact users. Next slide. So this is an overview. Primarily, most of these BSPs are ones that are used in the EPICS experimental physics in community, but I wanted to list them out because I know at least the sparks are the space. So Geisler has said that when the time comes, they will convert those to libbsd. Some of these BSPs are slowly in the process of being converted. I think the Motorola Shared and the Beatnik will be converted over in the next few months, but some of the others are just going to take time. So this is one of those transition points where some of the old hardware may just stick with the legacy stack, and that's the kind of option that open source gives you. Next. So I've mentioned a lot about WAF. This says we need a little bit of help wrapping up the switchover. There's might be some places where the documentation still refers to the old build system. There's a couple of automated part of the infrastructure for building things that the scripting that hasn't been completely converted over, but we're very close. One of the big things that's been added since 5 is the 64-bit AARC64 port. This is 64-bit ARM. It includes an ultra-scale BSP that currently works on QEMU and is being brought up on real hardware now. The networking is in the process of being brought up, and the plan is to add SMP. There is an STM H7 BSP, which should support any STM H7 series, which I think there's 8 to 10 of those. There have been some recent updates to what used to be Altera, but is now Intel NIOS 2 port. As I mentioned, the NVMe and SDMMC is pretty recent, and that's good. One of the other big things is that actually there's something called the RTEMS Central Repository, which actually has specification and requirements management. And because of this, we now have specifications for some of the APIs, particularly in the classic API. And those are, so the header files for those and that some of the documentation is actually auto-generated from the requirements input now. Oh, next slide. Pressing my spacebar is not going to help. So, I mean, RTEMS is ultimately a user-supported open source project, and that's what the core developers do. They help other users for their projects. We'd really like to get completely to libbsd and LWIP. So, yeah, whatever we're going to have to do to the legacy and update BSPs. We want to complete the transition to WAF, which should happen soon. One of the things that if you're just looking for somewhere to help, we've long wanted more code examples in the documentation that we'd welcome them. The Wi-Fi support is working, but it has some areas that needs improvements. I don't think you're going to deploy it in a satellite, but there. There's the two here I'll pick on, the microblaze port and a tech transfer of the RAD 750. Those have been out a long time. I'd love to see BSPs for the newer BAE boards. Obviously, having a Raspberry Pico BSP would be great. We do use Coverity and turn warnings up very far on GCC, and there has been work on C-Lang LLVM on a number of architectures, but it would be great to have static analysis more automated based on open source tools. Coverity is now run daily if any code changes are made. So that we're trying. If anybody wants help to help out on any of that, we'd really appreciate it. There's some other things like the C library doesn't have long double math support for a few targets. That'd be great. There are lots of inexpensive development boards. I mean, we really live in a great time for those. So if you've got any favorite development boards, we'd love to see a BSP for it. There's been a lot of work on paravirtualization, but I don't know that anything's publicly available on SEL4 yet. We'd love that. And again, pre-qualification artifacts for more of RTEMS. I mean, there's a space subset that would be from ESA, but nothing outside that subset's being worked on. But the infrastructure and process stuff is all there. Next slide. One of the odd things that's happened this year that we're happy about is there is now a textbook for RTEMS, and I'm not going to plug it a lot, but it's available now. It's the focus is really on the theoretical foundations of real-time embedded systems, and it uses RTEMS for examples, and it's available from Amazon, and I guess you could have it in 2 days if you were really eager and prime. Next. One of the things I like to see every year is how much traffic is actually on the mailing list. And you can notice that it has quite a bit trended up. I mean, we're seeing months now where it's in the 6, 7, 8, and 900 on the development list. And that list is where patches and discussion of patches are publicly occur. So that is a lot of activity. The users list is more general discussion. And it doesn't have as much traffic because a lot of the traffic seems to go toward the development list. Next. One of the really things I'm really pleased for is that we have a list for build results and automated test results. And this list has really picked up a lot of traffic. If you build the tools and have some permission to send to this list, which you can easily get, then you can send anytime you build RTEMS or test it on your hardware, you can send the results. One of the things internally not internally, there's a tool called RTEMS BSP Builder, which builds about 1,700 configurations of all the BSPs. and it generally takes from 12 to 34 hours to run, depending on the hardware you're running it on. And then this list includes test results from running various BSPs. In general, this list is hovering over 1,500 to 2,000 a month now. The other list that's posted here is the version control list, and every commit to any RTEMS.org repository lists in a post here. So you can generally see it fluctuates. I mean, there's been a peak at 1,000 a few years ago, but mostly it's hovering in the 150 to 200 range every month. Next. So where do the build reports come from? So there's on RTEMS.org servers, there's a BuildBot instance, which does spot checks, builds, and of 5 BSPs across a few architectures. OAR automates building Coverity scan updates for 6 once a day. Those are submitted because Coverity scan program is for open source programs. There's a limit to how many builds you can submit a day. Periodically, usually weekly, there is a build of all BSPs, all tools, and all BSPs, and a test run of every BSP that can be tested on a simulator for CentOS, FreeBSD, and Ubuntu. Doing one of these sweeps takes anywhere from, say, 24 hours to about 72 hours. The 24 is on an 8-core Xeon, so it is quite a long run. Occasionally, we'll post test results from BSPs on hardware that we have in our automated rack. From the community, you'll tend to see Chris John's post on Mac OS and FreeBSD, and you'll see Sebastian post on 5, 6, and 7 on SUSE and FreeBSD as needed. They mostly do them when the updates are triggered. Next. So the last thing I'm going to talk about is actually Deos+RTEMS, and this is a great example and a great product based on Deos and RTEMS. Deos is an ARINC 653 partitioned operating system, which has level A certification. And RTEMS can execute paravirtualized in one of the partitions. This can bring you all of the capabilities of RTEMS running in a paravirtualized environment alongside ARINC 653 applications and giving you that kind of criticality. The other thing here, which the open group FACE technical standard, which was started by Army and Navy Aviation, U.S. Army and Navy Aviation. The FACE technical standard defines 4 operating system profiles, 3 of which require ARINC 653 for criticality. So, and the Deos+RTEMS meets that requirement. Next. So the 4 profiles are security, safety-based, safety extended, and general purpose. Although general purpose is really just a larger embedded application. It's not particularly general purpose in the broader sense. RTEMS and Deos+RTEMS is currently approved as conformant for safety base. The key here is that the POSIX environment is single process and it's multi-threaded with about 250 POSIX methods. And ARINC 653 is required. Although we haven't gone through the conformance, we should also meet the safety extended profile, which has multi-process optional. So we would be single process, multi-threaded, but we would have more POSIX methods. Again, 653 is required. And RTEMS plus Deos aligns very nicely with the general purpose profile, actually meeting most of the requirements there. Next. So the way RTEMS is paravirtualized here, we end up using Deos like a hypervisor. So you can run an RTEMS application using either the classic or the POSIX API, Deos with its 653 APIs, or Deos with its own rate monotonic APIs. So this allows us to take pretty much an unmodified RTEMS application and run it as a guest. And you have access to some 653 services, such as sampling ports and queuing ports, to allow you to communicate between the partitions. Next. So the way this is layered up, you get your normal RTEMS user application layered on top of the very portable RTEMS libraries and the thread scheduling. And there is a layer of adaptation code that allows RTEMS to run on Deos and give you all these services, but it does not impact the portable nature of your application. So you get all the RTEMS services and you just run in a protected partition. Next. We're really proud we achieved phase conformance. We were certified to be conformant for the x86 architecture, and then we came back and did the ARM PowerPC in x86. So we actually officially meet the requirements of edition 3 of the FACE technical standard. And this is a big accomplishment. So there's on the order of about 100 requirements, and it means we have all of the POSIX and ARINC 653 APIs that are needed. Next. So as usual, the RTEMS project has been quite active. This presentation every year gives me a chance to reflect back, because everything that happens with RTEMS reflects that some user needed something and asked for something or submitted something. I think the pre-qualification effort is really exciting. It lays the groundwork for a lot of future activities, and we're always open to help improving things or help adding things or improvements to the processes, because anything we automate is better for everybody. So we've got kiosk sessions in virtual, and we're just happy just to have you come by and talk, not sit through another presentation. And you can feel free to email next at any time. So my contact information is in the next slide. So, and you can, if it's easier to remember, Joel at rtems.org, do that. But so that's all we've got today. I mean, if anybody's got any questions, I'm happy to try to answer them.
Yeah.
5, so we're probably going to be here a bit.
Yeah, we have a few more minutes. So first question in the Q&A is from Keith Morgan. If I wanted to help create a BSP for an ARM-based system, how would I get started? Is there a guide for creating a BSP for a new architecture?
Okay. So if it's ARM, it's not a new architecture, and you're actually lucky because a lot of the peripherals are the same across all of the ARMs or within all of the system on chips from a particular vendor. And yes, there is a BSP and device driver guide. There is also a guide on porting RTEMS to new processor architectures. But feel free to email me and we can go through whichever one you've got. It even turns out a lot of ARM peripherals are shared between the 32 and 64-bit architecture. So it's getting easier and easier to create ARM-based BSPs.
All right. Next question from Amale Oyaki. Does the RTEMS PowerPC BSP work on QEMU?
No, we do not have a current we do not have any PowerPC BSPs that work on QEMU, and I wish we did. I think there is one QEMU machine model that we identified that would be nice to have a BSP for. But right now, I think ARM, x86, and Spark are the only architectures that have a QEMU BSP.
Okay. Next question from Leonidas Komitis. Can you please provide some information regarding the graphics support for live BSD?
There's a lot of the graphics work lately has been using something called LVGL, and I honestly don't know much about it other than it's a simple, easy to use library for embedded systems. And somehow the drivers come over.
Okay. And we'll do one more question from Lee Garbs. He said he may have missed it, but what was the main reason for introducing live BSP? Simply to add a lot of functionality for relatively little effort, or were there other reasons?
Well, we had always used the FreeBSD TCP/IP stack, And one of the things we learned, and actually a lot of RTOS vendors and other OS vendors use the FreeBSD or NetBSD TCP/IP stack. But what we realized was that if we didn't take an approach to bring all that over in a repeatable manner, we wouldn't be able to upgrade it. So we've actually been through 6 major reversions of FreeBSD, and we have a rule called source code transparency. So we bring it over largely automated and unmodified. The rule is that maintaining your own TCP/IP or USB stack is a huge effort, and it's better to use something that's well maintained and robust. So the people who use those are more concerned with functionality than size, and the performance is really good. There's support for 10 gig E cards. So there's a lot of network drivers that just come over. So.
Okay, great. So Joel, there's a couple more comments, questions in the Q&A if you want to take those over to Slack, and we will move over to our next presentation. Thanks a lot, Joel from NOAR.